So in this video, I want to go through some examples of solving simultaneous equations. And each of these are in the form of y equals mx plus c. Okay? So when they're both y equals, like this, the method that you can use is to just put one equal to the other. So if we have these two equations, y equals x plus 1 and y is equal to 2x plus 3 for the first one, if y is equal to x plus 1 and y is equal to 2x plus 3, then the x plus 1 must be equal to 2x plus 3. Essentially, you can see it as replacing this y with the 2x plus 3, or vice versa, replacing that y with the x plus 1. Okay? You are essentially substituting one equation into the other. So some might refer to this as the substitution method. Okay? So, putting one equal to the other though, you can think of it just like that, if you like. So then we have this equation. Now we need to solve this equation. So let's subtract x from both sides first, and then subtract 3 from both sides. So we now have that x is equal to minus 2. So how do we then work out the y value? Well, what we do is we go back and substitute this into either of these two equations. It doesn't matter which one you substitute into, okay? What I would say is substituting into the one that looks easiest is usually the best bet, okay? So this one looks easier to substitute into than that one. Now I'm going to substitute it into both just to kind of show you that you get the same answer, okay? So if you substitute it into this one, then y would be equal to minus 2 plus 1. And minus 2 plus 1 is of course minus 1. Okay? If you substitute it into this one, you get y is equal to 2 lots of minus 2 plus 3. So 2 lots of minus 2 is minus 4, plus 3 is minus 1. So you get exactly the same answer. So you don't need to substitute it into both, okay? You would only do that if you wanted to check, really, that your answer was right, okay? So x is equal to minus 2, y is equal to minus 1. Some people would like you to just write your answer like that, okay? Or, if the scenario desires it, then if you're looking at where the two graphs intersect, then you can write your answer down as coordinates. So you would have minus 2 as the x coordinate and minus 1 as the y coordinate. Okay? So I'm going to finish off my answers by writing it like this. Okay, so the graphs intersect at that point, just for ease. Okay, so that's the first one. Took a little bit longer on the first one just to kind of get our eye in so we know what we're doing. So let's see if we can go a little bit quicker on the rest. So number 2, we have y is equal to x take away 3 and y is equal to 3x plus 1. So both of them are y equals, so we'll put one equal to the other and solve this equation. So let's subtract x from both sides. Then we can subtract 1 from both sides. And then divide through by 2. So x is equal to minus 2. And then I substitute it into either of the two original equations. And choose the easiest one. That's definitely the easiest one. So y is equal to minus 2 take away 3, which is minus 5. So the two graphs intersect at minus 2, minus 5. Okay? Right, that's number 2. So, number 3, we have y is equal to 2x take away 1 and y is equal to 5 take away x. Now they're both y equals, so we'll put one equal to the other. Let's add the x to both sides. We'll add 1 to both sides and then divide through by 3. So x is equal to 2. And then we'll substitute that into either of these two equations. Now, I think personally this one's looking easiest. So y is equal to 5 take away 2, which is 3. So the two graphs intersect at 2, 3. X is 2, y is 3. Okay. And number 4, we have y is equal to 3 take away 5x, and y is equal to 1 take away 2x. So they're both y equals, so we'll put one equal to the other. So let's add 5x to both sides so I can get a positive number of x's. So we'll have 3 is equal to 1, minus 2 plus 5 is 3, so 3x. Take the 1 from both sides and then divide both sides by 3. So x is 2/3. So then I've got to substitute 2/3 into either of these two equations. I think the second one's probably going to be easier. So y is equal to 1 take away 2 lots of 2/3. Now 2 lots of 2/3 is 4/3. 1 take away 4/3, well 1 is 3/3. So 3/3 take away 4/3 is minus 1/3. So the two graphs intersect at 2/3 minus 1/3. And that's my answer.